Greetings, this is Jim Lindsay. This is the Topic 7 lesson, and it covers issue 13 as you're reading in the textbook. And the question that we're asking here is, should scientists create artificial living things? So let's get to it. I'll start by showing you the resources for this topic. As you look at the Topic 7 folder on the Submit Assignments page of Blackboard, you're going to see, of course, the quiz and the issue analysis up at the top, like always. As you come down the page, you'll see the lesson that you're watching now, as well as a number of documents. You have a Word document. I actually have two of those. One is my notes. The other is a worksheet, which we'll get to it towards the end, and then a PowerPoint presentation, which you are welcome to download for sure. No matter what, get the notes, because within the notes there are links to some resources that you'll want to check out. So again, the resources come from the Topic 7 files that you're finding in the Topic 7 folder on the Submit Assignment page of Blackboard. All right, so let's start. We can move through this one faster than what we did with Topic 6 because they are related, and we've covered some stuff during the Chapter 6 lesson, the Topic 6 lesson, that is also applicable here. So that saves us a little time, which is nice. Again, here's the question that we were asking, and the learning outcomes for this one are what you see right there. As you look in the textbook, this lesson, this material starts on page 178 of the textbook, and it is a little bit longer than some of the other things that we've looked at, but all the material is well written. So you'll find that on page 178. We're going to hit each of these learning outcomes in some detail a little bit later as we get into the lesson. But first I wanted to cover, I wanted to show you what they were, and also what I wanted to do was talk about the authors real quickly and the currency of these articles. Okay, let's begin with the authors. The author of the Yes side is a presidential body, a bioethics presidential body, which was convened or appointed by President Barack Obama. And you'll recall that we talked about these presidential bioethics types of bodies back with Topic 6. In the last one, the presidential body wrote the No side. In this one, the presidential body wrote the Yes side. The author of the No side in this one is an environmental activist group called Friends of the Earth. In the last issue, in Topic 6, you'll recall that most of the resources that you were reading from were pretty conservative, politically speaking, pretty conservative groups. As I pointed you to several different resources. Most all of those would definitely fall on the right, over in the conservative camp. In this issue with Topic 7, it's sort of the opposite. The Yes and the No side in the group, which basically put together the materials that you're looking at, all sort of fall more towards the left, towards the more liberal side of the political spectrum. And so I just find that interesting, that there's that, all the information from one is coming from one side, and then, likewise, but on the opposite end of the spectrum with this one. So that's what you're hearing from. Let's take a quick look at, all about these presidential bodies. We talked about those, and how with these types of presidential bodies, a lot of what they find is discredited by opponents of the other end of the political spectrum, because they'll say, hey, this body is just saying what the president wants to hear just to justify their policies, etc. We've talked about all that with the last topic. Let me give you some more information about the Friends of the Earth group, because I think it's relevant. Okay, so I'm in my notes in that Word document I told you that you should download. And as you come down the page here, as you get to the bottom of page 1, the information you see right here starts talking about this Friends of the Earth organization. This is an environmental advocacy group. I have a couple of links out here for you to visit in your browser. what those look like. I'm just going to show you the first one, Who Are We group here. This is from their webpage, foe.org. It talks about their mission. It talks about where they're located. They're out of Washington, D.C. This is a group which basically, as you can see from their mission statement right up here, they're looking to promote things that basically will help with the health of the planet. And they're specifically fighting against what they see as corporate bodies doing things with greed in mind, which ends up hurting the environment, but puts money in their pockets. And so this is with the Friends of the Earth organization. That's their mission. This is some information about them. This group, and it's sort of like a Greenpeace kind of group. If you've ever heard of Greenpeace, they have definitely gotten criticism. And as I have a couple of Guardian articles out here for you that you can see some criticism within the environmental world about this particular organization, talking about, hey, they're in it for themselves. They're not necessarily in it for the environment. So there's some skepticism about whether their motives are true or not. But I think what they write is it's something that you definitely maintain an open mind as you read it. But please, as you read both the yes and the no side, maintain that open mind and healthy skepticism and question what you read, and try and go out and corroborate it. Another reason that you need to corroborate all the things that you're seeing is just the how old these articles are. Again, as we pick textbooks and things like this, that's constantly a struggle when you're talking about technology. These articles come from the yes side was written in 2010 and the no side was written in 2012, and so those are pretty old. And so both the yes and the no speakers of this side, you definitely can go out and get a lot more current stuff that's going to support your side of the argument. Again, we're looking at 10 years old and 8 years old at this point as far as the yes and the no side. So feel free to go out there and please do get some more current sources as you research. The body which put this whole thing together is called the Hastings Center, and this is also this is a fairly well-established and recognized bioethics sort of think tank. You can see it was founded back in 1969. This also has a reputation of being, left of center with its political leaning. And so, again, the people which put together these articles, the yes side, the no side, that's some information for you, and you've also got some information about their currency. What they're talking about in this issue, I wanted to just cover some basic terms and get us all sort of at least using the same bar, setting the bar. So as we talk about these different terms, I wanted to do that first. And then from there, hit those learning outcomes going forward. But what they're talking about in this issue is something called synthetic biology, which I was not familiar with until just a number of years ago. And so maybe you're a biology major, maybe this is something that you've studied before, but for me, this was something that was relatively new. And so let's establish what synthetic biology is first, and then let's talk about the specific story which acted as the catalyst for this set of articles, and then we'll get into those learning outcomes. That's what we'll do with the rest of our time. Okay, so let's start with the defining what these things are. When you hear the term biology, what comes to mind? And this is where it's fun in the classroom, where we get to talk about different things that people have experienced in their high school careers, in their early college careers with regard to biology classes and what those were like, and things that they enjoyed from those experiences, as well as some people are really advanced in this. Some people are nursing majors and pre-med and stuff like that, or biology majors, planning to go on to actually be PhDs and this stuff. And so the amount of information that can be shared about this is pretty cool. But it's the study of living organisms, right? And so that's what biology is. It's something you probably have experience with at 7th, 8th grade, freshman, sophomore year of high school. You're doing some sort of biology work, typically in high schools. So this is something that's not especially foreign to people, but that's the base term that we're talking about. So biology. Now, the next term that comes into it is synthetic, and what does that mean? And that is people have heard it for sure, but people haven't necessarily thought about what exactly does that mean. And as we wrestle with that as a group, what it basically comes back to is that you're talking about a substance that's typically been made through some sort of chemical synthesis. And so there's been some sort of chemical process which has occurred to make something. So if you talk about synthetic biology, what does that mean? That definitely makes it a lot more complex, a lot more challenging. When you think about synthetic things, when you think about commonly purchased synthetic items, those things may include oils, diamonds, wigs, leathers, urine, weird stuff is being made, medicines being made chemically to that we consume on very much very large levels, consuming products made synthetically. So when we get to synthetic biology, I'm going to basically just read you a definition here. This is from bio.org. Synthetic biology is an interdisciplinary discipline which involves the application of engineering principles to biology. It aims at the redesign and fabrication of biological components and systems that do not already exist in the natural world. Again, things that do not already exist in the natural world. So, hopefully that got your attention. I mean, we're talking about studying life which basically has been created. And so that's what we're talking about with this particular issue. And so it's pretty likely that you haven't done a lot with this because it is pretty advanced biology. And so unless you're one of those biology majors, you may not have a lot of experience. So hopefully you're seeing some cool stuff. So the next thing I wanted to cover with you just very quickly before we talk about the story which acted as the catalyst for this set of articles is a couple of computer terms, because the metaphors used to explain how the synthetic biology works, one of the guys, Dr. Craig Venter, who you're going to be hearing a lot from, he often makes references to computer stuff because it helps explain the process they go through in order to create life through this chemical process. And so let me cover a couple of computer terms with you and then talk about the specific story. All right, so let me try and remind you of something that we covered the very first issue when we started talking about technology and the Internet of Things. We talked about computers and what a computer was. And hopefully you'll recall that we started talking about computers as universal machines for processing data. You have this machine that is going to behave differently based on pieces of software or programs that the user selects. And so the sets of instructions that are chosen by the user will result in different outcomes, different uses of the machine. It's a very unique technology in that regard. And so so you know what a computer is. We established that well back, month and a half ago, 2 months ago. And so now this whole idea of what is software, let's just explore that just a little bit deeper. It's the intangible part of a computer system. There's hardware, software. The hardware is the stuff you can touch. Software is the intangible part. It's the sets of instructions which are written by humans to make the hardware work. As we study software in the 100 level classes of in the information system classes, we talk about two different types of software. We talk about system software and application software. The type of software that makes hardware work is called system software. And one of the three examples of system software would be operating systems, drivers, and utilities. Those are three different types of system software. If you had CIS 141 with me, this should be like, oh, I remember that. And so as you start to hear from Dr. Venter in a second talking about this synthetic biology work, he's going to be talking about how they took a cell and they replaced the operating system of the cell with through synthetic biology, and as a result of that, the proteins and things that cell started to then create and the way that it started to behave, the living being that it became as a result of reprogramming the operating system, these are the terms that he uses. An operating system is again one example of system software, and examples of operating systems that you probably have experience with would be like the Windows operating system, the Mac OS X or OS 10 operating system, or maybe Linux. Those are different operating systems. What those sets of instructions, with those lines of code, again written by humans, do, they tell the processor how to execute instructions that it wants to. That's what the operating system is. And so having that sort of frame of reference as you get over to the interview, which I'm about to point you towards, hopefully these things that he's saying are then going to start to make a lot of sense. So these are computer terms that you're going to hear mentioned, specifically the operating system and software, and that's what they are. So as you think of that metaphor going into the biological realm, hopefully it's going to help make a lot more sense. So let's get on over to the story itself, and that has driven all this discussion, or these stories. Okay, so as you read the introduction to this issue or this topic on page 178 of the textbook, it talks about how on May 20th, 2010, the Venter Institute announced that it had engineered the first self-replicating synthetic bacterial cell. And as you dig into the details of that, maybe not necessarily from the book it'll give you some of the details, but as you have these other things I'm making available to you through the notes, you'll learn that basically what the Venter Institute did was they took a cell and they removed all the stuff in it, except think of like if you're back in your biology classes, and you in my biology class, I remember this from 7th grade. The first thing the biology teacher did was he gave us like wine corks and razor blades. It sounds like a terrible situation with 7th graders, right? And so with these razor blades, what we had to do is cut off really thin chunks of cork, and then put those on microscope slides, and then look inside of look through the microscope and basically see the cell structures in place of cork. Now those are pretty much empty, those, because it was dead, it was cork. But in a living cell, a living thing, if it had come right off of a tree, there would have been a whole bunch of stuff inside the cell. And so what the Venter Institute did was they took this particular bacterial cell and they scooped all the stuff out but left the cell wall in place. And then through synthetic biology, and you'll hear about it from him when you watch the video I'm about to direct you towards, they repopulated that. They basically filled that back up with stuff that they made through their own creation using chemicals. Think back to, again, like your biology classes when you learn about DNA, and there's adenine, guanine, thymine, and cytosine, right? And those different things go together to make DNA. And so you can buy that stuff in bottles. You can buy adenine, guanine, thymine, and cytosine in chemical bottles. And then if you have the right kind of equipment and know how to do it, you can put those together so that you make your own DNA strands. And so they did this and then put that stuff back into that empty cell. And after putting that back in there with the DNA back in the cell, and then letting the cell kind of heal back up there or close back up, that cell started to function according to the DNA that they put in there that they had made from bottles. It's just like, oh my gosh, this is crazy. And not only did it start to function, it then split and basically became a living being and started to split. And so that's what we're talking about with the synthetic biology. It's amazing. The complexity of it just blows my mind. And as you look at this, the jcvi.org website as an example of one place that does synthetic biology, it's just incredible how intelligent. And this is not new, as you're going to hear from the video. This has been, at the point when they did that in 2010, they'd been working on it for a decade, I think, maybe 15 years. So that was the result of lots and lots of work, and now it's been 10 years since then, right? And so as you look at their website, and you'll see as you scroll through here, I mean, this is current. They're working with coronavirus stuff. As you get to some of these images, like they're trying to help do something with regard to the coronavirus and figure out what its genetic code is and how to attack it from that front. But as you scroll through this page here, you'll see that there are different things that they do, one of those being synthetic biology. If you open that up and look at it, it starts to talk about different projects which they have been working on. And what's interesting is where they get their money. And that's one of the things I want you paying attention to, because this stuff has to be just crazy, crazy expensive. And so one of the places which the Venter Institute gets its funds is from organizations, from businesses. And so one of those being the petroleum industry, like BP's and Shell and big petroleum companies. And what they're trying to do is create some stuff that would be used specifically in those industries. And you'll hear him talk about one particular algae that they're working to create in the video. Again, the video is old at this point. The video is from like 2010. And if you continue to look at the website here, you'll see that they've made some progress, but this stuff is so hard. They're still not completely done with this stuff. Does that mean that it's impossible and that they're just tricking these companies and just taking their money? I don't think so. I think it's just so difficult that it's going to take a really long time. But this one of these algae projects that they're working on is with the petroleum industries, and as a result of that, this particular algae could then create its own fuel that we could use in cars. Just amazing. Like, wow, that is so cool. And so instead of having to dig oil out of the ground, we could use it through this synthetic biology process, create algae, which is, they can do chemically create it, which is very inexpensive. And then as a result of that, what it creates just by its being alive, it excretes this fuel, which we could then turn around and start to use to heat our homes and power our cars and things like that. So it's those are the type of projects that these people are working on. They're really hard projects. So let me show you the video I specifically would like for you to watch. Venter, so let me jump over to the PowerPoint. I'll be right back. Okay, actually what I did, I jumped to my notes, the Word document. There is a link here for theguardian.com/science. You can see this link right here. Again, this is from May of 2010. If you open that article at theguardian.com, it looks like this. And as you scroll down this page, what you'll see, there's a video at the top of it. And it'll take a second to populate, but I want you to watch that interview with Craig Venter, and he's talking about this stuff that they have done. Okay, I had to click on it. It's saying, like, do you want to register? And I said, not now, and it loaded up the video window for me. I started it just so you can see a snapshot of what it looks like. That's what Dr. Venter looks like. It's short. It's about 12 minutes, 45 seconds. as you watch that, you're going to hear him referencing the terms I was talking to you about a second ago, like an operating system and computer software, and how how they took cell stuff and they replaced it, and then the resulting behavior of the cell which they reprogrammed. They rewrote the code genetically for this being, and then how it started to behave. And then he starts posing questions about, like it's impacted him in a way. He starts, thinking differently about what life exactly is. What exactly is life? And then, and that's where it gets really philosophical, and all sorts of ethical questions start to come into play, right? And so, very complex issue. So I want you to take a quick watch of that. And it's not super quality. You can make it bigger. Again, this is from Ian Sample from The Guardian. Did this interview, and it looks like it was sort of through like a Skype sort of thing. You'll hear like a cat in the back, or you'll hear like Outlook reminders and stuff like that. Just kind of look past that. The fact that you're hearing from the guy that led up this initiative, I think, is really cool, because you then get to hear from one of the minds which basically was very involved in this whole idea. So that's what synthetic biology is. That's an example of what drove this whole question of, like, should scientists create artificial living things? Because it can be done. Now, did they go out and create the entire cell? And no. They took an existing cell, they scooped it out, they put other DNA that they thought up into that cell, but they're not. It's not like they're acting like they're not like God. They're not creating something completely from scratch, but it's still what they did was very, very unique at that point, and so that's really what's driving this whole conversation. So over my notes, I have a couple of time hacks mentioned, like here and here. Just again, it's only about 12 minutes, 45 seconds. Watch the whole thing. So you can see some of my notes right there. As you look at the issue analysis for this topic, I reference this and I ask you to think about some of the things that he mentions, and then your ideas about what potentially is beneficial, who would that benefit exactly, and also to talk about some potential threats which these ideas may pose to society. And so, again, the link to get to the Venter interview is right here. Let me show you the issue analysis so you can see the specific question. So you'll see for the issue analysis for this topic, question 4 is asking specifically about what I just showed you. And I want you, looking at that algae that we talked about with flu vaccines that he starts to mention. And I wrote this question long before like the coronavirus stuff came around. Like, what if this synthetic biology could be used to more quickly create a coronavirus vaccine? I mean, why wouldn't we want that, right? And so I want you thinking, how might those things be beneficial? How might those things be harmful, potentially? And those are the questions which we're wrestling with as we work with this issue. Okay, so let's go back to so now you know what the issue is. Now let's just briefly look at the learning outcomes and identify some of these things. The first learning outcome was discuss synthetic biology and the ethical questions it raises. There are many of those, right? And so as we look at these ethical questions, let me just kind of give you what pops into my mind. There are physical concerns. In addition to physical concerns, we're also going to have philosophical and ethical concerns. Let's look at the physical concerns first. And so as we think about just issues of physical safety for humans and issues of physical safety for the environment. Let's say someone's working on a synthetic biology project and everything goes exactly as planned. They're able to basically get that whole synthetic life form created, and it does exactly what they thought with no side effects. Great. Maybe that's, and maybe it has no negative potential safety concerns for the people, the humans working, in the labs with it, or out in the field or out in the rest of the world outside of the laboratory. That's what when we talk about the field, we're talking basically outside of a laboratory. So let's say that thing works perfectly and exactly as expected, and nobody is impacted in any weird sort of ways by this genetically created or the synthetically created organism. Great. But what if it doesn't? What if what they create actually, it does what they thought, but it also does things X, Y, and Z? Or let's say it doesn't do what they thought it was going to do, and it does things X, Y, and Z. At that point, you get into questions of like, ooh, is this really going to be safe for the public? Is this going to be safe for the people that have to work with this thing? And likewise for the environment, let's say they're working with this algae to create fuels for our cars and for our homes. What if this fuel that they create is this algae? There's no natural predator that would normally eat this algae or compete with this algae, so this algae just goes crazy and takes over all sorts of coral reefs and starts killing coral reefs. This is just these are ideas I'm having. So those are ideas about physical safety concerns which may arise from synthetic biology or organisms created via synthetic biology. Now we also look at philosophical and ethical concerns. Obviously this stuff is super complicated. Do we actually know enough to be fooling around with this? Are we basically starting to enter a realm which is beyond our comprehension, and as a result of that, are we going to do some stuff that is again damaging? That's one of the are we playing God when we follow these sorts of use these sorts of procedures to create synthetic life? To what degree is financial motivation part of this whole process? Think back to that Venture Institute, which is funded by things like petroleum companies like BP. At some point BP wants to get their money back from all this money they've invested in the research, right? So if you're at the Venture Institute, do you, even though this thing that you're going to create might potentially kill some coral reefs, but it's going to make BP happy and they're going to continue to give you money, what do you do at that point? These are ethical dilemmas which people in industry face, right? And so these are some physical and some philosophical ethical concerns which come to my mind, and I look forward to learning from what you guys what you think about as well. Okay, one last component of this, and whether I place it here or could have placed it where we talked about just a second ago, one of the technologies which drives this is genetic modification, and one of the tools you already learned about back with topic 6 was something called CRISPR. Remember that CRISPR tool that I showed you? And I have another link to another. It's about a 5.5 minute video that I think does a pretty good job of at this point, knowing what you know from topic 6 as well as what you've already learned about from this lesson. It'll make CRISPR make even more sense. But let me jump over to that link real quickly. All right, this is about halfway down page 4 of my notes. There's this. It's from a TED Talk. Basically, it's like from a recorded sort of TED Talk sort of thing from Andrea Henley talking about this CRISPR product. But if you check out that video, it will, again, in about 5 minutes, explain like the whole Cas9 protein and how that's used to deliver the specific set of DNA letters that you want to specific points within a DNA strand, and then how it goes from there. So check that out. Again, this is all sort of falling under this whole learning outcome A, what is synthetic biology, as well as what are some ethical concerns that are raised by it. Let me jump back to the PowerPoint presentation. Okay, and so as you read especially the no side of this issue, one of the things it talks about, or some of the things that it talks about in that no side, it starts talking about ways which synthetic biology could be dealt with to make it less dangerous. If it is dangerous, you may not even think it's dangerous, but if you think it is potentially dangerous, how might you deal with it in, in how could you mitigate those threats, those potential dangers that you may face. And so it introduces this idea of something called a moratorium. And so I would ask you, say, hey, with your neighbor real quickly, decide, what does the term moratorium mean, right? What is that word? And so you guys would discuss it. You guys would come back and say, hey, well, a moratorium is when you stop doing something. You just pause. It's not a complete stop, it's a pause. And then I would ask you, okay, give me an example from industry, from business, where a moratorium has been, basically put in place, and who put that moratorium in place. Give me an example of a moratorium from business. And so that's one of the things I would ask you to do. And I would give you a second to think about it. And it's cool to hear your thoughts about this, because you guys think about different things that I wouldn't. One of the things that's currently, I think a good example of a moratorium being implemented has to do with vaping. And if you, with vaping cigarettes or vaping products, which are an alternative to cigarettes, right? And so I have a couple of links to some news stories that have to do with this, but you'll recall back from 2019, probably in the summer of about 2019, maybe in the late spring, we started to hear in the news about lots and lots of cases of lung problems. People are dying from weird lung problems, and people thought it was linked to vaping. And so as a result of that, the CDC, the Center for Disease Control, which you hear so much about with regard to the coronavirus, they basically advised municipalities to implement a moratorium on vaping products. And so let me just jump over to a quick story I'll show you. Okay, I have an NBC News story from September 2019 talking about this, and then a Washington Post follow-up story that talks about Massachusetts specifically, and how it basically put this moratorium on the products, and basically people were not available for a period of time. And so this is an example of a moratorium. The reason I bring this up is that as you read through especially the no side, and they talk about ways with which maybe synthetic biology could be examined and dealt with, is to implement things like moratoriums on either synthetic biology in general or specific types of synthetic biology. And if you're not familiar with what a moratorium is, that doesn't make a lot of sense. So, bringing this to your attention, saying like, hey, that's when you basically pause, and then you reassess and figure out, is synthetic biology really dangerous, or are vaping products really dangerous, and specifically which ones, and what makes them dangerous. That sort of those sorts of questions are the thing you're asking with a moratorium. So I wanted to make sure that I brought those to your attention at this point in the lesson. So let me jump back to the PowerPoint. Okay, so now we look at learning outcome B, or the second one. Explain and begin to evaluate the idea of the precautionary approach. And so I wanted this precautionary approach. I wanted to make sure you knew what that was. And where you look in the book to learn about this is you look at pages 188, 189. And so I'm just going to read you a quick snippet of something that talks about this. All right. When an activity raises threats of harm to human health or the environment, precautionary measures should be taken even if some cause or effect relationships are not fully established scientifically. Now that's important. So basically, you have some sort of thing which you think may be causing some sort of trouble, but you're not sure. If you're using the precautionary approach, you still stop. You still either do a moratorium or you completely stop. And that's because you don't know yet. In this context, the proponent of an activity, let me rephrase that. Basically, in this context, the people that want to do something like the Venter Institute, which wants to do synthetic biology, rather than the public, they bear the burden of proof to show that it doesn't cause harm. So with this precautionary approach or this precautionary principle, you're placing that burden of proof on the people that want to do something. And they go a little further. They basically say the process of applying the precautionary principle must be open, informed, and democratic. Basically, everybody has to be transparent so people know. Let's use the synthetic biology example, or synthetic biology as an example. If people were going to be using the precautionary approach with synthetic biology, then the Venter Institute would need to tell everybody exactly how they're doing things, so they could then do testing themselves. They could, and where does that, why wouldn't you want to do that? Well, if you're the Venter Institute, you spent the last 25 years trying to come up with this technology, you can see why that would be proprietary in your eyes, because, hey, I've spent 25 years of my life to do this and millions of billions of gazillions of dollars to come up with this. And so, no, I don't want to tell you exactly how it works. But using this precautionary approach or principle, it's saying that, yeah, you need to share with people how this works. And it needs to be democratic in the sense that people that are potentially affected need to get a vote in whether this sort of thing proceeds. And so that's the precautionary approach. And what I would do in a classroom, and this is where we don't have the opportunity right now, but this is where we'd start to do a lot of work together in the classroom and start to look at some things that are potentially they're controversial, potentially dangerous. We want to look at some of these and examine how the precautionary approach or principle might be used with those sorts of technologies. So let me jump over to my notes. I'm in my notes and I'm at the section that starts talking about learning outcome B and what the precautionary approach is. And I have a link out here to x.company. And this is a Google X website. If you've never seen this before, I'd like for you to open this website. When you look at it, it looks like this. Google X is a Google initiative. Again, Google does all sorts of stuff, but what this particular part of Google is supposed to be working on is, as you can read through here, they're trying to come up with innovative solutions to really hard problems. And so some of the stuff that they come up with is very radical, and it's potentially like, that's crazy. But what they're, again, as you read their mission statement, they're trying to come up with solutions to really tough problems that don't just make like an incremental improvement to it, that they make the problem better by 10 times. And so that's, as you read through here, these different things that they're doing, it starts to make sense. And so I have a worksheet which we would work on in class, and I'm going to show you the worksheet. It looks like this. It's one of the things that you hopefully will download from the website. Do you turn this into me? No, you don't turn this into me for a grade, but it's going to be something that will help you get this. I mean, it's so, spend a few minutes on it. This issue 13 worksheet is what the document is called. The front page of it, called the precautionary principle. You would work on this with somebody during class. And I'd say, hey, you take one topic, you take another topic that you find over at the X company website, or something you did from like your week one controversial impact sort of technology, and answer these questions about what you're reading about. And so as you look, let me give you an example. So over here at the X company site, like that one that you saw right here, as you scroll down this page, it starts talking about these different projects that they work on. I'm going to click specifically on projects, and I'm going to come down to the one that has to do with those kites right there. This one right here. So it's energy kites, and they call it Makani. And as you click on the little arrow for more information, I just think this is really cool. And so as you read this, what they're doing is they're taking a plane, like a big wing, and they're creating a windmill out of it. And as you come down here and start to read about this project, they're trying to come up with ways to get clean energy in places where you can't put, maybe there's not coal energy, there's not gas energy, they don't want those things, but there's not room to put like a big wind turbine. What this sort of kite thing does is and they have schematics and stuff like this for it. It has this wing that's going to float because it's in a really windy location, but in addition to that, it's going to float and fly around like a kite because it's a kite. But it also has propellers on it, and what the propellers do, they're linked to a wire which is tied to the kite itself, which comes back to a ground station. And so they throw this. They basically have this thing flying, and you can see video of it. So they have this kite basically flying in circles on this wire, and while it's flying, because it's not doing any sort of pollution, but because these guys are turning because of the wind, it's creating power which comes down through the wire, which feeds into the power grid for that particular location. And so this is one of the things you'd think about, like, okay, so now I understand what it is. As I look at this worksheet, does this pose any threats to you humans or the environment? Well, no, it's not going to pose any threats because, it's making clean energy. Yeah, but what if you're a bird and you live in that area? What if you're like a robin or a cardinal and you like to fly through that space where all of a sudden there's this decapitating kite flying around 24/7, or, at least as long as it's windy? So are there any sort of threats or what if you're a person that, you're a pilot and you want to fly your plane through that area, or if you're a person who lives where one of these things, if it wrecks, does that damage your home or something like that? So these are the sorts of questions I'd ask you to think about as you complete this worksheet. It's just the first page here. So these are questions you would ask as you work towards analyzing a technology using this precautionary principle. So that's one of the things I'd like for you to do. Again, do you turn it into me? No, but I think and just do it for one, think about one of those things, and I think that's going to make you more informed and better understand these whole ideas that are being presented in the yes and the no sides of this article. Okay, so I didn't even show you guys my GIF. I got a GIF for a. If you look up GIFs of people crossing the street, they show you some pretty scary GIFs because a lot of people almost getting hit by cars. They want to do that, but I thought that was kind of funny. So we've talked about these things about what the precautionary principle is. I've told you about the worksheet. The last thing I wanted to bring up with you is this learning outcome C, or the third one. Identify regulatory strategies for limiting the risks of emerging technologies. And we've kind of covered this because when we talked about AI and whether it should be regulated, I used to not do that, but now we've talked about regulation already. So the amount of stuff that we need to talk about with regulation is definitely diminished. So that's what we'll be talking about next with this, with the remainder of this presentation. I would ask you what a regulation is, and you would tell me it's a rule or a law or some sort of governing sort of policy, right? And I say, can you please give me some examples of regulation? And because we've already talked about some of the stuff, you'd come up with some of those very quickly. And I'd say, okay, well, let me just ask you some questions and see what you guys think. So I'd say, what about this? Let's say your parent calls me, your mom, your dad, your guardian calls me and says, hey, John Doe, Susie Q is in your class, they're your student, and I need to know what their grade is. My question for you would be, may I discuss your grades with your parent? And if you don't know, the answer is no. There's something called FERPA, which is a regulation which basically has to do with student privacy. And I've had to do this on a number of occasions. I say, I'm sorry, mom or dad, if you want to know what your student's grade is, you're going to have to talk to your student. I cannot tell you what that is. By penalty of law, if I do share that information with you, then they can sue the university. And so, no, I cannot share with you what, your son or daughter is how well or poorly they're doing in a class. It's just not something I can share with you. Now you can fill out like FERPA waivers and stuff, but as teachers I don't really see that. And so my answer is always to the parents like, no, I'm not going to tell you what the grade is, talk to your kid. So that's one example of a regulation. The next thing I would ask you is like, I'd give you just an outrageous situation and say like, hey, I live close to campus and I like watching that TV show Moonshiners, and so I was thinking like, hey, I could do that. So what do you guys think? What in my backyard I should put together a still like this, and and then I can sell like moonshine when people go to football games because they walk past my house as they go to the stadium. And of course that's stupid, and I wouldn't do that. I would never do that. But one of the reactions I got one time was just it was really funny. One guy was really upset about that. Like, no, you're going to blind people, and it's talking about like how dangerous it is to work with those sorts of chemicals and things. But again, like in that case, it's there are all sorts of laws talking about who can and cannot make alcohol and stuff, like alcoholic drinks and things like that, right? Because you can really you can kill people if you do it wrong. And so again, just another example of regulation. The reason I bring that up is that as you read in the textbooks, again, especially on the no side, again, as a means of dealing with synthetic biology, it introduces the idea of regulation. And so I would ask you, like, so how does a regulation differ than a moratorium? I want you to be able to know the difference between those because they are different. We've already discussed a moratorium. What is a regulation? How do those things differ from one another? And then furthermore, who's going to, and that's where we get to the last thing. Let me jump back over my worksheet. I'll be right back. If you come down to the second page of the worksheet, you flip it over, it says, okay, think of one of the two things that you worked with on the front side with, when you did your precautionary approach or principle work over here, as you come over here and start to answer questions about regulations. Who would come up with regulations to make it so that these potential threats that you identified were dealt with? And who's going to enforce those regulations? Can that be done at the commercial level, or is that something that's going to have to be done at, with a government agency? And why? Is that something done nationally, domestically, or is that something that's done internationally? And why? And so again, these are all the sorts of questions that we want you asking as you guys wrestle with complex issues that you hear about in the news that you're going to deal with in your business lives. Okay, so I'm going to jump back to my PowerPoint and finish it. So you saw the regulatory strategies worksheet that I would like for you to, again, do you turn that in? No, but if you do that, you're going to be better prepared to complete the issue analysis as well as take the quizzes and just understand this material. So in conclusion, we've talked about what synthetic biology is. We've talked about specifically the Venter Institute and their work, which led to the creation of these articles, which we're examining. We've talked about these different learning outcomes and things like moratoriums and regulations, as well as we've looked at how synthetic biology works and what CRISPR's component is inside of that. And hopefully you've enjoyed it. Thank you for your time and your attention. I look forward to reading your thoughts in the issue analysis. So please contact me with any questions, and have a good night.